We did this one last time. Let's choose another. So let's say the integral from 4 to 16 from natural log x dx, and we want to use the leftmost point, the rightmost point. What do we want to use? Leftmost point, rightmost point. Which one?
Leftmost point.
The left?
Sure.
No, I just didn't hear. Is it the left? No, you choose. I just didn't hear what you said.
Left is fine.
Okay, good. So let's say 3 subintervals. Even easier. So if this is 4 and this is 16, then the delta x, which is the width of the interval, is 16 minus 4 divided by 3. So that is 12 divided by 3, and this is 4. So this is 8 and 12. 1, 2, 3 subintervals. If we want to use the left, then we have to calculate the height here. If we want to use the right, then we would calculate the height here. And why not? Let's do both. And see what happens. So the left area with 3 will be base, which is 4, times f of 4 plus f of 8 plus f of 12. The right area with 3 subintervals will still be 4, but this time we start at 8. F of 8 plus f of 12 plus f of 16. That will be the difference between the two. That's it. So, graphing calculator. I go to stats, I edit, clear, 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 and we have 4, 8, and 12. 4, 8, and 12. And what I like to do is just go to highlight the list L2, and I will just put 4 times natural log of list L1. And when I click enter, it will give me all those numbers that I have to add up. I'm not going to add them up by hand. I go again to stats. I do calculations, one variable stats, and list L2, not list L1. I couldn't care less about list L1, and just calculate. And this is the sum, 23.8026. 23.8026. Now if I want to do the same thing, I go to the table. No, I don't go to the table. I go to this table first, because I have to change the x values. And they are now 8, 12, so 8, 12, and 16. I will not change anything else. I will go to stats again, one variable stats, on list L2, of course, give me the calculation. So it didn't calculate basically because I have to redo. No, I have to redo. It cannot be the same. So I have to redo list L2. It didn't recalculate. I thought it would, but it didn't. Okay, so I have 4. I have natural log of list L1 and enter. As you see, the numbers have to be different. And I go back to stats and calculations, one variable stats. Yes, list L2, just give me the numbers. So the sum now is 29.347, which makes sense. They cannot be the same. If we calculate with the leftmost point and calculate with the rightmost point, they cannot be the same. So 1, 2, 3 gave us 23.8. 1, 2, 3 gave us 29.34. Where is the actual? It's definitely between 23.8 and 29.34. Guaranteed. What is it? Okay. We are equipped to do that as well. Not us, but the calculator can. So that's number 9. And we want it from 4 to 16. We have to get a number between 23 and 29. 16, natural log. Okay, dx. When I hit enter, we have to get again a number between 23.8 and 29.34. That's 26.82, as expected, between the lower and the upper. Because the calculator has a way of determining the antiderivative for this. We have other methods. So for this problem, we can't. We don't study those methods in this class. But for this one, we cannot. We don't have a method for that. But for this one, we do. But it's not a method that we study in this class. It's called integration. It's called integration by parts. Very good. Perfect question. So let's go back. So again, I didn't mean to stop sharing to share. So again, I'm hoping that this will be just a piece of cake for you. You don't have to do it as I did it. You can just determine these and add them up. It's more difficult, especially if you're not used to plugging in the function in the graphing calculator as I do. It will be more difficult because you may make an error. But I put the function in and I determine each value in a blink, and then I add them up. You don't have to use stats to add them up. But if you determine this by hand, step by step, and you determine this by hand and not have the function entered in the graphing calculator, it will be more difficult for you to get the correct answer. So I highly recommend, please, enter the function in the graphing calculator if you don't want to use the method that I presented. So enter the natural log in here. So natural log x. And then determine, you plug in 4, and then 8, and then 16. I'm sorry, 12 I meant to say. And then add these up. And see what you get. And then don't forget, you have to multiply by 4. After you finish adding these up, you have to multiply by 4 in front. So that's another option. I don't want to add these up. I prefer the calculator to do that for me. So that's why I use the one variable stats on list L2. And when it calculates, it gives me all sorts of things, but I'm only interested in the sum. I don't care for the mean, I don't care for the sum squared, I don't care for the standard deviation of the sample or the standard deviation of the population and minimum, maximum. No. I only care about this. And that is the sum, without having to enter and too much work to do. But at least you can just add them up. Okay, enough of that. Anything else you would like to go back to? So again, this problem, I hope, is not going to take more than 3-4 minutes of your time. At the most. Anything else? We looked at the linear regression. What about the d-test? Is everything okay with the d-test? Partial. I'm sorry?
Can we do the d-test?
Right. So you know you have to basically use the partial derivatives, right? Create a system, get a point, and then find a d-test. Do you have a problem that we should look at?
I don't have a problem now.
Okay, so the d-test is in 6.3. I hope I'm not logged out. We also had an example last time. Let me see, where is it? Three, page 576. Okay, would you like to choose?
Can I pick one?
I'm sorry?
Could you pick one?
I will pick one. I will pick 3. I don't know why. I'll pick 3. 4xy minus x to the third minus y squared. Perfect. Okay, so remember we have to find in step number 1 fx. So fx, we differentiate with respect to x, we have 4y. With respect to x, negative 3x squared. With respect to x, nothing. Fy, with respect to y, 4x. With respect to y, nothing. With respect to y, 2y. In step number 2, we have to set them equal to 0. 4y minus 3x squared. It's like finding critical numbers, the same thing. 4x minus 2y equals 0. Okay, so let's say I am solving for y. So I have 4x equals 2y, or y equals 2x. Good enough. I will replace it by substitution in the first equation. 4 times 2x, 8x. Minus 3x squared equals 0. One option equals 0. And the other option is 8 equals 3x. So x equals 8/3. So we have 2 possible points. One point will be 0, 0. And the other point will be 8/3, comma 2 times 8/3, 16/3. Now we have to find in step 3, we have to find fxx, fyy, and fxy. fxx is negative 6x. fyy is negative 2. fxy is 4. Now the d-test is fxx times fyy at these points minus fxy but squared. So for 0, 0, fxx is 0 and fyy is negative 2, so still 0. And this is negative 4 squared, which is negative 16. Less than 0, nothing. Now let's check 8/3, comma 16/3. So the first one is negative 6 times x, so simplified negative 16 times fyy, which is negative 2, minus 16. So this is positive 32 minus 16. I don't care about the number, it's positive. So d is positive and fxx is negative. So 8/3, comma 16/3 gives a relative mass. What is it? I have no clue. I have to plug it in. So f of 8/3, comma 16/3 is 4x times y, so 4 times 8 times 16 divided by 9, minus x to the third, so 8 to the third over 27, and minus y squared, which is 16 squared over 9. I have no idea what that gives, but I have a calculator. So 32 times 16 divided by 9 minus 8 to the third divided by 27, and then minus 16 squared divided by 9. 9.48. Let me see if I can change this. I didn't mean that. I meant this. So 256 over 27. So 256 over 27. And this is approximately, again, what was it? 9.48. So again, I'm hoping that this will not take too long. Once you find fx and fy, set them equal to 0, find the point or points, then go back and find fxx and fyy and fxy, and determine, put in the formula for d, and determine whether d is positive. If it's not positive, or if it's negative or 0, nothing. But if it's positive, then look at the first number. If this is negative and this is positive, relative max. If this is positive, relative min.